Here's an example of a word problem. So this is trigonometry in the real world, or at least in the real world as imagined by someone who wrote a word problem. This one says a model for the average high temperature in Las Vegas is given by L equals 80.60 plus 23.5 cosine pi over 6t minus 7.01 with L in degrees Fahrenheit and T in months where T equals 1 corresponds to January. What is a period of this model? All right, remember, period, here's the B. This is actually the K, and sometimes you can put the K in the beginning. K plus A cosine B x minus C. So remember, the B tells us the change in the period. So period equals, for cosine and sine, it's 2 pi over B. In this case, B is pi over 6. That's 2 pi times 6 over pi. And the pi's cancel. 2 times 6 is 12. And then it says indicate the units. That's 12 months. So that means these averages repeat every 12 months. The average in January is going to be about the same as the average in January, and February to February, and March to March. So every year, the months are going to have the same averages. So this stuff repeats every 12 months. Repeat every 12 months. Put that in words so the teacher understands, you understand that that's what it means. It means this is a cycle where the average temperatures repeat in 12 months. Average temperatures in June of 2011 would be the same as the average temperatures in June of 2012. What is the maximum average high temperature? Well, sine and cosine mean that there's some midline. That's what the K is, the midline. In this case, the K is in the front. So that means the line or the value that it's fluctuating above and below. So that would be the average. So here the average is 80.60. That's the midline. And then it goes 23 above, 23 below. We'll go 23 above because they asked for the maximum. So 23.5 above. And what do those two add up to be? 6 and 5 is 11. 3 and 1 is 4. 8, 9, 10. 104.1. 104.1 is the high temperature. So that is an example of this in the real world. Now there is another example in the worksheets, and let's see if I can find it. Let me see if I can find it, because I'd like to work that one too, but it may take me a moment to find it, and I won't be able to edit this video because I don't have time. So let's see if I can find it. It had something to do with a Ferris wheel. Here it is, the Ferris wheel. I found it, and it didn't take super long time. Let's look at the Ferris wheel. Whoops. What's that? That was sharing. Let's look at the Ferris wheel example. And then that will be the end of this video. Let's go down to the Ferris wheel. It says a Ferris wheel is built such that the height above the ground of a seat at the wheel at time t can be modeled by, here's our graph, 53 millimeters, where h is in feet. What is the period of the model? What is the meaning of the period? Well, whatever multiplies t, in this case, is the b, so period equals pi over 10, not pi over 10, 2 pi, which is the period of sine, divided by pi over 10. So that's 2 pi times 10 over pi, and that equals 20. Now, what is t in seconds? So the period is 20 seconds. It means that this wheel completes one rotation in 20 seconds. Man, and if you've ever been on a Ferris wheel, the more you ride it, the more you say, man, speed this thing up. I want to go around fast. So, okay, one rotation of the Ferris wheel in 20 seconds. What is the amplitude of the model? Well, the amplitude is whatever's in front of sine, so the amplitude is 50. 50 what? What is the meaning of the amplitude in the context of this question? I'm trying to scroll over. Context of the problem. Well, it says that h is in feet. So that means, remember, that this value is the average. So that would be at 53. Okay, my line isn't exactly horizontal, but that's at 53. And so then this thing goes 50 above, 50 below, 50 above, 50 below. That means the seat, the height of your seat, is going to fluctuate as the wheel spins. And it goes, and it fluctuates. It goes as high as 103, 50 plus 53. That's the high. And it goes as low as 53 minus 50, which is 3. So you're only 3 feet above the ground. And these are feet. So again, when you're on a Ferris wheel, when you get to the top and you can see all in the distance, you say, man, I wish this thing could go higher. I want a bigger wheel. Bigger and faster. But anyway, that's what the amplitude means. It means as the wheel spins, here's your seat at the bottom, you're 3 feet off the ground. And as you spin and get to the top, you're 103 feet high. So that's your top height. You can see a lot more at 103 feet. So that's another little example of a practical application, at least as far as what something writes in a word question, of sine and cosine. This one happens to be sine. That's it. Make sure you work those reviews.